Jennifer Bohart from SCC, and in this section we will be reviewing fractions. Now example 1 asks us to express a mixed number as an improper fraction, and the procedure for this is given in the box. You want to start with the denominator. So we have 7 times the whole number part of the mixed number, which is 3, and you add the numerator, which is 2. Then you take that, divide it all by 7. Now it becomes an order of operations problem. We have, this is equal to 7 times 3, which is 21, plus 2 divided by 7, which is equal to 21 plus 2 is 23 over 7. So 3 2/7 is equal to 23/7. Over here on the right, we have 12 1/3. It's going to be the same procedure. Start with the denominator, which is 3, times the whole number part of the mixed number, which is 12, plus the numerator. All of that divided by, in this case, 3. Now multiply. 3 times 12 is 36, plus 1 over 3 gives us 36 plus 1 is 37 over 3. So 12 1/3 equals 37/3. Now in example 2, we're asked to work the other way. Express the improper fraction as a proper fraction or a mixed number. So this first one, we have 42/5, and what we want to do is set up a division problem. We want to take 42 divided by 5. Now looking into this, 5 goes into 42 8 times. 8 times 5 is 40. 42 minus 40 gives us 2. So this division problem we have set up gives us 8, remainder 2. So back up to our fractions, 42/5 is equal to 8 2/5. Same procedure over here on the right. We have 53/9. Setting up a division problem, 53 divided by 9. 9 goes into 53 5 times. 5 times 9 is 45. Subtract. 53 minus 45 gives us 8. So we have 5, remainder 8. Back up to the fractions, 53/9 is equal to 5 8/9. Now in this next section, we have equivalent fractions, and if you take a look at the diagrams here, it's important that you notice that the same amount of each diagram has been shaded. Over here at the right, we have the rectangle divided into 4 equal pieces, one of which is shaded. So this represents the fraction 1/4. The next one, we have the diagram divided into 8 equal pieces, 2 of which are shaded. So this represents 2/8. And the last one, we have the diagram divided up into 12 equal pieces, 3 of which are shaded. This represents the fraction 3/12. Now if you look at these diagrams, it's important to notice that the same amount has been shaded in each one. So the shaded region is the same for all 3 of these diagrams, which means that the corresponding fractions, 1/4 is equal to 2/8 is equal to 3/12. These all represent the same number, the same value. All right, these are what we call equivalent fractions. Now another way to find these is to start with a fraction. I'm going to start with the 1/4 and multiply the numerator and the denominator by a number. Any number except 0 will do. So I'm just going to pick 2. 1 times 2 over 4 times 2. In the numerator, 1 times 2 is 2. 4 times 2 is 8. So 1/4 is equal to 2/8. We could also try multiplying both numerator and denominator by 3. 1/4 is equal to, on the top we have 1 times 3, on the bottom 4 times 3. As long as you multiply by the same thing on the top and bottom, you're okay. In the numerator, 1 times 3 is 3. In the denominator, 4 times 3 is 12. Now this will work with any number you want to multiply by, any number except 0. So let's just pick something a little bit larger. We have 1/4 is equal to, how about 15? We have 1 times 15 in the numerator, 4 times 15 in the denominator. Multiplying, we have 1 times 15 is 15, 4 times 15 is 60. All three of these are equivalent fractions. They represent the same value, the same number. So in example 3, you're asked to find two fractions equivalent to, in this case, 2/7. So you really can pick any whole number you want. So let's start with 5. We have 2/7, and let's multiply both numerator and denominator by 5. 2 times 5 is 10. 7 times 5 is 35. 10/35 is equivalent to 2/7. All right, another one, choosing another number, how about 11? 2 times 11 over 7 times 11 is equal to 22 over 77. So 22/77 is also equivalent to 2/7. Now in example 4, you're asked to write in simplest form. Now this is the same idea, but you have to be more careful with the number that you pick. So here we have 3/18, and we're asked to write it in simplest form. Now in this case, instead of multiplying, we're going to divide. We want to reduce the fraction down to lowest terms, to the point which the numerator and the denominator have no factors in common. So if you look at 3/18, 3 and 18 are both divisible by 3. So I'm going to divide both the numerator and the denominator by 3. 3 divided by 3 is 1. 18 divided by 3 is 6. So 3/18 in simplest form is 1/6. Now our next one, we have 42/54. Both 42 and 54 are divisible by 6. So 42 divided by 6 in the numerator, 54 divided by 6 in the denominator. 42 divided by 6 is 7. 54 divided by 6 is 9. So 42/54 is equivalent to 7/9. 7/9, 7 and 9 have no factors in common, so this fraction is reduced. Now before moving on to example 5, I'm just going to draw a little line here. When reducing fractions, it's sometimes difficult to figure out the largest number that is a factor of both the numerator and the denominator. So another way to go about this, let me just start with the same fraction, 42/54, is to start with smaller numbers. If you look at these two values, 42 and 54, both numbers are even, so you know that both of them are divisible by 2. So start by dividing out the 2. We have 42 divided by 2, 54 divided by 2. 42 divided by 2 gives us 21. 54 divided by 2 gives us 27. All right, that worked. But the problem is the fraction is not quite reduced yet. Both 21 and 27 are divisible by 3. So in another step, divide out the 3. 21 divided by 3 is 7. 27 divided by 3 is 9. 7 and 9 have no factors in common, so now it is reduced. Now, these two methods will always work when reducing a fraction. You could either reduce the fraction all at once in one big step or in smaller steps. Either way will work. If you notice, our answers for both were exactly the same. Now in example 5, we have some special cases of fractions, special cases involving 1 and 0, and you need to know what to do with each of these, starting with 1/4. Now the way this fraction is set up, the denominator always tells you the number of pieces into which the whole is divided. So 1/4 would look something like this. You have the whole divided into 4 equal pieces, one of which is shaded. So that is your 1/4. Now comparing that to 4/1, remember the denominator tells you the number of equal pieces the whole is divided into. So in this case, it's divided into only one piece. Now the numerator tells you the number of pieces you have, and that is 4. So you have 4 of these. So looking at these, you have 4 wholes. So this is equivalent to 4. So 4/1 is equal to 4. Now the next one, you again have in the denominator a 4, so the whole is divided into 4 equal pieces. The 4 in the numerator tells you that all 4 are shaded. So 4/4 is equal to 1, where whenever you have the case where the numerator and the denominator match, where they're the same non-zero value, the result is going to be 1. The next one we have 0/4. Again, 4 in the denominator tells you that we have the whole divided into 4 equal pieces. The 0 in the denominator tells you that none of those pieces are shaded. So essentially 0/4 or 0 over any number will always give you 0. Now the last one on this list, I have 4/0. And if you think about taking a whole and dividing it into 0 pieces, that can never happen. 4/0 or any number divided by 0 is undefined. In mathematics, you can never ever divide by 0.